Hello, so let's take a look at alkene nomenclature this time. So our rules for naming the alkenes are pretty much what we have seen before when naming the alkanes, with just a couple of caveats to add. Now, of course, the name ending, that suffix for the alkene, is going to end in ene instead of ane when we're talking about the alkanes. We are looking for the longest chain, just as we were for the alkanes, but now we've got the extra caveat that it's got to be the longest chain that contains the pi bond, or pi bonds if there are multiple. That defines the chemistry of the molecule and the name we want to give it. We're going to give the lowest possible numbering to that first pi bond that we can find. That doesn't mean that we're going to number according to the branches. So even if we could find a branch at an earlier point on another end of the molecule, that doesn't matter principally. It's about the lowest possible numbering to the pi bonds. Now, if there's a tie, and that pi bond would have the same numbering from one side or the other, then we'll look to the branches to see if there's one side that we should start from. Of course, those branches, once we've got them locked in, we'll list them in alphabetical order rather than numerical order. That's the same with what we did for the alkanes. And do watch out for examples which have multiple double bonds, multiple pi bonds. If there's 2, we'll call it a diene, 3, a triene, 4, a tetraene, etc. So let's take a look at some examples. And the 4 examples we're going to look at today are here below. So let's get started on the first one. So we're looking for that longest continuous chain with the pi bond itself. That's 4 carbons long, based on the alkane butane, but of course we change the name ending to ene, butene. We'll lock in the numbers for that main chain, 1, 2, 3, 4. And so that double bond specifically begins on carbon number 1, and we add that to the name of the alkene, so but-1-ene. We only need to mention the number for the first carbon in the pi bond because it makes sense that the second carbon or the next carbon will be the end of the pi bond. So but-1-ene. We've also got those branches on the molecule, and giving this the exalted position of carbon number 1, it means that the branch appears on carbon number 3, so it's a 3-methyl branch, and that gives us the final name of the molecule, 3-methyl but-1-ene. Let's look at our second example. Again, looking for the longest continuous chain of carbons that contains the double bond. That longest chain is going to be 7 carbons long, so it's a heptene derivative based on the alkane with 7 carbons, heptane. Notice that that isn't the longest continuous chain. We could have had 1, 2, 3, 4, 5, 6, 7, 8 carbons if we didn't care about that pi bond, which defines the chemistry of the molecule. So locking in the chain numbers to give that pi bond the lowest possible numbering, it puts the pi bond on carbons 2 and 3, so we name it as hept-2-ene. Again, we only care about the first carbon in the double bond. We have got a branch in the molecule, of course, which is 1, 2, 3 carbons long, so based on propane, but because it's a branch, we take off the ane and give it a YL ending, just as we did with the alkanes. Remember, a carbon can't be part of the branch and part of the main chain at the same time. So this is the first carbon in the branch. So that locks in a name of 3-propyl hept-2-ene. Let's look at the next one. We've got a cycle this time, but again our longest continuous chain of carbons, which contains the pi bond, is 5 carbons long in this cycle. So we get cyclopentene. Locking in the position of the double bond itself, because it's part of a ring, the 2 carbons in the bond have to be carbons 1 and 2. We don't care about that for the name of the alkene, because once we know it's a cycle, the double bond has to be the first 2 carbons. But it is important for naming the side chains, the substituents in the molecule. So we've got an ethyl branch on carbon number 3 and a fluorine branch on carbon number 4. Of course, just as we did with the alkanes, we'll name those branches in alphabetical order rather than numerical order. So we get 4-fluoro, 3-ethyl cyclopentene. Notice that we have to be careful with the numbering of that main chain as well. Carbon 1 is definitely here because it means the branches are on carbons 3 and 4, the lowest possible numbering. Whereas if we had started here and made this carbon number 2, then our branches would be on 1, 2, 3, 4 and 5 rather than 3 and 4. And that's the final name for the molecule. 4-fluoro, 3-ethyl cyclopentene. Alphabetical ordering to the branches. The halogens end in an O, so fluorine becomes fluoro. The alkyl branches end in YL, so we can distinguish them as branches compared to that main chain. And with the alkene bond being in a cycle, we don't have to worry about the numbering for the double bond position because we're assuming it's on carbons 1 and 2. Our last one here. Now we've got 1, 2, 3 carbons in the main chain, and our longest continuous count for carbons has to include all 3 of these pi bonds. That's easy enough because it's really the only alternative we have. So based on the octane with 8 carbons, we've got octene. Locking in the position of the pi bonds themselves, we get a lower number for the first pi bond by starting on the right hand side here, carbon 1, rather than the first pi bond appearing on carbon number 2. So that locks in the pi bonds at carbons 1 and 2, 4 and 5 and 6 and 7. But of course we only care about the first carbon in the pi bond each time. So it gives us octa 1,4,6 triene. We've also got some branches on the molecule, and those occur in carbons 4 and carbon 6, both bromine. So it becomes 4,6-dibromo for this alkene, and that's of course our final name, 4,6-dibromo octa 1,4,6 triene. Of course, we have some stereochemistry with these alkene bonds, which we haven't mentioned. We'll get to that in the next video. I hope that helps. And again, as always, ask me if you have any questions.